add in a marker. All right, beginning. So today we are going to start the conversion over to entities, because I think that that's where the book is taking us. Slowly we're moving over into an entity component system. So in our world, we're going to want to have a list of all of our entities here. So this dot entities, and that's going to be an empty array, as it were. And we have this run here, but I think what we're really going to want is an update method. So at the bottom here, we're going to have an update method. If we need to bring in anything into update, we'll bring it in here. And then we're going to loop through all the entities and then run the update method on them. So that's going to be this dot entities dot for each. We're going to have an entity, and we're going to run entity dot update. And so that's going to be pretty simple for what we're doing there. Then what we need to do is register an entity and add it to the world here. So we can have an add entity, maybe a register entity. This is going to take in an entity, and we are going to just say this dot entities dot push entity. All right, so that's gonna allow us to add in the entities. We don't necessarily have a way right now to remove an entity, so that's going to be a little bit interesting, because when the trees, like remove trees off screen, we're gonna have to get rid of them when they're dead, as it were. So we'll deal with that as soon as we get there. For right now, let's just go ahead and add them all on, because we're gonna have trees not be here anymore. We're gonna put the trees in the entities. Okay, so let us now in the main world, so in the main, like the game, we want to start putting all the things in here. And maybe the first thing is the trees, because we know that we create these trees right here. Chance to create the tree. I don't know if the world should be handling this. Maybe that should be done in like the main part of the loop. Although I think this needs some information, doesn't it? Create tree, right? So this like creates a tree and then adds the tree to the system. Let's do the other ones first. They'll be simpler. So we have we don't need the playground. Okay, so we have states. We don't care about that. We have the event system. We have the game. We have the game states, globals, index, input handler, obstacle. Okay, so the obstacle is something that can definitely go into here. So let's go ahead and make sure the obstacle has an update method. It does. We also need to pass in the velocity and the player. Okay, so the velocity and the player is what it needs. So let's go ahead and make sure that in our, where is the actual main game? Game.js. So in draw, we have, where's our world created? Input handler, game state. Wait, is our world not created here? Our world is only in game data or game state. There's a game state. Okay, so here's where we create the world. So I'm thinking that the world should actually be created in like that main game, not in the game state. And if we do that, then in our main game, we can register the new entities, which would be, for example, the obstacle. We could do the obstacle first. All right, so this.world. Let's go ahead and refactor this to be away from here. Then we won't need like the get world or anything like that. Where is world used? Just on get world and storing the world. Okay, so that's gonna be simple. We don't need you, and we're not gonna need you anymore. So save you. That causes a problem. That's fine. In our main game, we're gonna do let world, and in setup, initialize it. So we're gonna do world equals new world, like that. Then down here in draw, well, I guess like in here in like world, we now need to add in, what was our first thing we're gonna add in? Actually, because we have multiple obstacles, maybe we should do player first, because we have a list of all of our entities, right? We have trees, we have players, and we have one player, and we have two obstacles. So let's do the player first because it's just singular. And the player only has like this update method that doesn't need anything else. It just handles it all on its own. So that's going to be really simple here. So in our game, we have new, we have world. Where does the player get created? I think that's under game state. So in game state, we have this.player, and we create the player, and we have these events that are added into them. So these will have to now be outside as part of like the main game too. So take you out, bring back to game here. Let's put you up there. Okay, so we're gonna have our game state, our world, we create our player, and then we're gonna register our player with the world. So world.register entity and player. We don't need this to be a this.player. It's just gonna be player like that. Then in world here, so input handler is rebinding. So we don't need to run when we're rebinding. If the game state is running and we're not rebinding, okay, so here's where we're going to say world.update, like that. And everything works. Well, sort of. The space doesn't actually reset. All right. It does work. Do we create trees? I don't think we create trees. We broke that. However, the scores are working, and we're able to, like, the obstacles are working. So step one is done. The player is now an entity and registered. Although, wait, did I not save? I didn't save all this stuff. Let's make sure I save it all. Okay, yeah, we're broken again. So let's find out what I did wrong. Jump over obstacle event is not defined. So where is that? Okay, so new obstacle, jump over obstacle event. I think I took that out here because jump over obstacle event, the player needs, and collided event. So that means when we create the world, we need to pass this event in for right now, and then we'll handle that. So let's do in our world. And I just want to do like one tiny little update at a time, make sure that we're working still, and then we'll refactor the obstacle in. So in our world, let's get the, it wants the jump over obstacle event. So in game state, actually, this is game state that needs it, not the world. Game state needs jump over obstacle event. Okay, so take you, go to game state, and our constructor, we're going to take in the jump over obstacle event and therefore initialize it into there. So save that. All right, now what? Collided event is not defined. Okay, so where is collided event used? GameState.js line 13. Collided event add observer. Okay, so that means here's our collided event. We also need to add you in here. Okay. Collided event. And here you take in a collided event. All right. Can't access property render. GameState.getPlayers undefined. So game.js line 30. Right, so now we're calling render on this. So I think that should be part of the world thing. So we should be able to say, okay, world.render, like that. And then we go to our world. We're going to have a render function. And it's going to be the exact same thing. We're now going to call all of our entities. And so for our player, what do you need when you render? Nothing. You just do it on your own. So we'll do this dot entities dot for each entity dot render. Easy. Can't access property update, GameState.getPlayers undefined. So game.js line 31. All right, so GameState.getPlayer.update. Well, we're already updating, so we don't need you. Can't access property location, player is undefined. This is obstacle line 44. So an obstacle line 44, that's because we do is right of player when we pass in the player. Okay. So where does that come from? The game.js line 33. Right, okay, so we have this obstacle.update here, and we're passing in the run speed and then the player. So this is interesting now because world now owns the player and we don't know where the player is in the world. So we're going to need to do some kind of query with world to get the player out to then hand it to the obstacle. Or we put the obstacle into the world as well, and in update, and I think this is why in ECS systems you have like the systems that are separate. So that's the function that's sort of doing that updating on the entity. So we have the entity, yeah. So that's going to be interesting. So if we want to get the player out, now I mean I could just pass the player in. Although this is accidentally creating a global, and we didn't want that to be. Hold on. Let's make you a const. So this goes out of scope right here. World is the only one that has the player, and it's just in an array. So we don't actually know. I mean, we know it's position 1, but we don't really know that it's the that is the first position in that array. In a real game, there would be tons of things in that array. So we could try like a method to get the player out of the world, and then we can pass it into obstacle for right now. And that might be useful later when the obstacle in the world needs to get the player. So in world here, if we have a type in, so if we like have a little type field for our player. So if we do something like this dot type equals, and so we're doing class-based stuff here. This would be interesting. I wouldn't necessarily want to put this here. Every single entity is going to have a type. So I could do, this is where I could have an extend. So a little bit of inheritance. We're going to have for our world, we're going to need another class, specifically an entity class that our players, our obstacles, everything else is going to take from. Let's go ahead and where's our index.html? This is all fun. Let's just add in an entity. So here is entity.js. And we're going to make a class entity. It's going to be a very simple class. We're going to have a constructor here that's going to take in a type. And we're going to say this dot type equals type. So all entities have a type. So it could be player, it could be something else, and that's really what it is. We could also have the types that we care about. So we can have const types. This is where it like potentially could be an enum type thing. So types, it's not really a constructor, so I don't know, I'll just use types, lowercase like that. And so we could have player right now is just player. And the only reason I'm doing it like this is this way I can now say, okay, I can grab the values out of here. And essentially it's a little tiny bit of type safety. It's not really doing it in type safety version. It's just doing it in more of, did I spell it correctly, safety. So in our world, let's see. Now it's going to be in our player. Where did our player go? Our player's over here. In our player, we can now extend, and this is entity. And we're going to take in, we don't need to take in a type. The first thing we're going to do is we're going to call super, and we're going to hand in the type, which is going to be the types dot player. That's what we are. Which means now, in the world, if we want to get a player out, we can get by type, essentially. So get by type, or get entity by type. So we're going to take in the type, and we're going to return the object from the world, and it's probably going to be just a filter of them, because if we have multiple of them, then we want to get all of the objects from that. So we're going to return a filter. So this dot entities dot filter, we have an entity, and if the entity dot type, if that is equal to the type, that's what we return. So that will get an array of all the entities. Okay, let's see. Then this is all in support to get location players undefined for the obstacle. So the obstacle needs, where is it? Line 44 is right of player. That happens in the game on line 33. So right here, meaning that we need to get the player at this point in time. And the only reason we need that is just so we can pass that in here, and then later on that method might be useful, it might not. It's just part of the refactor at this point in time. So const, essentially this is players. We know it's players. I'm just using that because we know it's going to be an array. We know there's only going to be one, but let's not worry about that. So this is going to be world.getEntity get entity by type. And we're going to pass in the type, which is types.player. Okay, so that's going to give us, now we have an array of these players, and we know that, so obstacle, it's the get player. We can now pass in players position 0. Can't access property, check if hitting, game state that get player is undefined. So this is game.js line 35. So get players, this is also players of position 0. Now this is interesting. So for each obstacle, we now want the player to check if the player has this method, check if hitting the obstacle. Now, what if I want some kind of like system method that checks if one entity is hitting another entity? Then I could get the entity by types and then check that. So that could be a method off of the world. That could just be a function that we use. I could also just put the function down here somewhere, and then we just run it whenever we want to. So if we do something like that, where we have, okay, let's do player hitting obstacles. So if I do function is player hitting obstacles, what is that? Is player hitting an obstacle? Is player hitting an obstacle? Then what do we need for this? Well, first of all, we need the players. So we need essentially the world to come in. So we'll bring that in here. We need the obstacles. So for right now, we'll take in the obstacle. And that would allow us to now replace this code with this code down here. So is player, so is player hitting another obstacle? We're going to pass in the world and the obstacle in question here. Now, obviously, this isn't going to do anything because it's just an empty function. And there's more things here, so we need to actually implement this. So is this, yeah, we need to figure out what the player is doing during that code. So let's go find that. Check if hitting the obstacle, this essentially, this if statement needs to be completely moved over into the, so remove it from there, back to the game, you go in here. Okay, so we have the obstacle, so that gives us that, and now we need the player. So const players equals world dot get entity by type, types dot player, and now all of this will be the players of position 0. Okay. Can't access property score. Game state that get player is undefined. Game.js line 56. Right, because the player, okay, so the player is keeping track of its own score in this game. Now we have the player right, like the player's right here, but that's in this if statement, and so that's gone. So we just want to do this again here. We could have like the system that prints out the scores. We can pass it the world, and it can do this, and that could be fine. Or we could just do it like another const. I kind of like the idea of maybe another function to like print out the score. So function print. This is like the interface. So print interface. Maybe draw interface would be right. Which we know we need to take in the world. For this, we take all of you, and we're going to cut you away. Going to put you down here, and then we need to get the player. So const players equals world dot get entity by type, types dot player. And now, and then I realized, you know what we can do? This is just an array. So we can put this in an array like this, and we'll get the first item. So destructure out of here. So that's our player. And now, instead of GameState.getPlayer, it's now just player.score. All right. So the game kind of works. The game moves forward, the player updates, it runs forward, the player can hit the obstacle, that's good. As soon as I try to restart the game, we get an error. So what's next? Can't access property reset, GameState.getPlayer is undefined. So that's in game.js line 70. So this is in the restart game command. We're going to need to take in the world. You notice, like, I'm making this more functional. So I know the world is available to us in general on this file, but I'm making it so that I can now pass the world in, and it's a little bit of a dependency injection here. So I can now grab the player out. So where is it? Game player.reset. So we're going to say const player equals world dot get entity by type, types dot player. And now get game state that get player is just going to be player dot reset. Okay, so what's next? Can't access property, get entity by type, world is undefined. Oh, I need to pass in world, right. So when we restart game, so restart game is game.js line 69. Wait, no, that's when it's trying to use. Line 21. So commands for each command, instead of, we have GameState.getPlayer for this command. Do we want that or do we want the world? Get entity by type. So we need to pass in the world. Actor that handle input is not a function. So yeah, the entire like command system is gonna have to like be changed to probably not commands anymore. They might be systems. Let's see what this is. So actor.handle input is not a function. That's line 66 now. Right, so we have our actor here. We're gonna handle input and it's gonna be the jump command, this function. So restart game, we saw this takes in the world, but it's a command. What was this before? It was nothing, right? Right, because sometimes it's the actor. So this is the world. And we need, like, the player is the only one that can jump. So const player equals world dot get entity by type, types dot player. And so then this is going to be player dot handle input jump. Okay, I can jump. The game ends, and we go from that. The score isn't being printed out, and I think that's because I forgot to actually call draw interface from here. So we have the end of this if else if statement here, and we need now to draw interface. And you take in the world. So there we go. Ooh, our score gets 1 even though if I hit that. So that was incorrect. And everything seems to be working. The trees aren't drawing though. But that's okay. We can update that as soon as we get them into the world. So I think the next thing will be is to pull the obstacles in and make them part of the world. All right, so before I do that, I want to open up our, send this all to GitHub, because if we need to do a refactoring, at least we can come back to this state. So stage those changes. All right, so we refactored player to be an entity. And we'll push that. Okay, next up. We want to put the obstacles in the world too. So we want to register them. So, I mean, the first part is going to be easy, right? We need to create the obstacles up here in the game and then register them as an entity. So right now, I think the game state is doing that. So here's our obstacles. We're no longer going to need these here. We're going to just create these obstacles like this. Let's go ahead and grab you out, and we're going to take you away. We're going to go back into game, and we're going to we're going to now instantiate like world.register. Let's do this after our player. So world.register entity, and it's going to be this new player. Sorry, register entity obstacle, and the exact same thing over here. World.register entity. There we go. All right, so now we have 2 obstacles and register entity here. And now we have to fix all the bugs that come with this. So that's cool. Can't access property location, player is undefined. Right, so now in player, in obstacle line 44. Here we have is right of player. And that's based upon here. So update for obstacle has this a velocity and player here. And so I could try to like figure out, okay, update, you're going to like take, you know, a velocity and player in, except the player doesn't need that. So at this point in time, we need to rethink, how do we want to run this function? And what's the entire point of this? So like the location add velocity, that doesn't need, oh, that's like the speed increase. That should be something else that we really worry about. Like the obstacle should have its own velocity inside of here, and then we can update the speed by updating both the obstacles in here. So let's go ahead, and for the first part, we'll just create our velocity inside of here. So this dot velocity equals, and we'll set it to some P5. So I think that's a create vector. And our X is going to be maybe like -1 and 0. And now we don't need velocity anymore. So this dot location dot add velocity. Okay, that's fine. Now the second thing is we take in the player. And that allows us to get is to the right of player, but the entire point of checking to see if we're to the right of the player is to notify that the player jumped over the obstacle event. So just notify the event system that we've jumped over. Okay, that's fine. And then we call reset with this too. So I think these two functions that's fine. This is probably, reset is probably okay for this. It's just going to be our up, this one right here. So we need another function, essentially a system here for determining if we scored. Like that's kind of all we're doing here. So let's go back to game, and let's just do that here. So function, did we score? Did we score? And we're going to take in the world. And we're going to do this calculation here, which means we won't need the player anymore. So is to the right of player is to, okay, so the entire point of this is, are we to the right of the player, and the next frame, are we now to the left of the player? That's all we're caring about. And it sounds like we're not even doing it right because they're giving it a point when we're not really to the left of the player. And it's like the middle of us is to the right of the player. So let's just start this over again. So we're going to remove you, and we're going to remove you. So that's going to set up our update. That will be fine now. Our velocity is set up like that. That's all good. Velocity is undefined. line 25. Right, because you're going to be this dot velocity. Can't access property for each. Game state that get obstacles is undefined. Okay, yeah, so get game state is now like trying to do stuff for this. What we want to do now is have that function that's going to determine, did we score here? And so we're going to take in our world. We're going to have to take in some, what is it? It's going to be that event, which I think is in game state. Where did it go? I know when we created the obstacle, right, we have this player jumped over obstacle event. And I think in game now, here's jump over okay, so here's the jump over obstacle event. We are going to want to make this more of a global thing. Okay, so first of all, obstacle, you no longer need to care about this. It means you no longer need this here. Our game, this is necessary for us to sort of set up, but we are going to make this more of a global here. So we initialize it in our setup. Const, we have our collided event. All right, so we'll deal with that later. So we have our world, we have our player. We register entity obstacle no longer needs this jumped over obstacle event. Okay, so that's happy there. I mean, happy is relative. We have other issues. So did we store? We need to implement this. We probably want to get everything running first, because this is like once we get it running, then we can actually determine did we write this correctly here. Okay, so can't access property for each. Game state that get obstacles is undefined. So in game.js, line 35. All right, so here's where we want to render the obstacles and update the obstacles. And we no longer need, we no longer need, so update, so world.update is going to handle this. And world.render should handle that. Let's see, game state line 35. Okay, so game state that get obstacles for each obstacle is player hitting an obstacle. So we're also going to need this to be an external sort of system, as it were. So function is, oh wait, is player hitting an obstacle? I have that as a sort of system right here. But because we have obstacle, we no longer need this because we're putting the obstacles in the world. We don't need that anymore. Now we're going to want to get the obstacles from the world. So up here, this entire thing can go away. So save view. All right, that's working. Now this is a little bit slow and we don't have like the increase of speed, but everything is working right now. So the first thing is we have this entity. We now want to add in an obstacle type. So obstacle is type obstacle. Say view. We're going to go to obstacle and we're going to extend. And in our constructor, we're going to call super and pass in types.obstacle. So that way we can now do our queries to grab that out. Super is only valid in derived class constructors. Oh, extends entity. Okay, so now we have our obstacle that knows that it's an obstacle, and now we can query entity for that. So in our, because we notice we just ignore those. Let's go ahead and go back to the game here. And we have these systems that we need to deal with. So did we score, and is player hitting obstacle? Let's do this first. So we have players equals this, and we know we can refactor this to be a player. And now instead of players like this, it's just going to be player. And now we can get all the obstacles. So const obstacles equals world.get entity by type, types.obstacle. That gets us an array of obstacles. So now we can loop over these obstacles and run this off of there. So now we're going to, and this is runs the player collided event. Okay, well that's pretty easy. So for obstacles for each obstacle take you in there, put you in there. And now let's see if this just works. As we wait for a painfully slow obstacle to run into our player. Nope. It unfortunately did not. Okay, so let's see what happens here. We have our obstacles. Is this even running at all? Let's put a console log in. Wait, did I not save? I just realized there's the little dot there. Let's make the obstacles a little bit faster. That will help out. -5. Okay, yeah. So we're not actually colliding with them. Let's and it's gonna be player collided event notify that we collided with an obstacle. So let's start with a console log here. Is this running? So console.log obstacle. No, okay, so our obstacles that world.get entity type, are we not? So world.register entity, new obstacle, and we create the vector of where they are in the world. But wait, are we running this? Is player hitting the obstacle? We're not running the function. That's the reason why it's not doing anything. So in our, if we're running world.update, let's go ahead and actually run that function. So is player hitting obstacle, and we pass in the world. There's our console log. Hey, and we hit the obstacle. We can't reset the game yet, but one thing at a time, right? All right, so now we can hit the obstacle, and we can end the game. We can't restart the game yet. That ends. That sort of fails. Okay, so can't access property for each game state to get obstacles is undefined. That is game.js line 73. All right, so here is our restart game system. We're going to take in the world here. And so we have player. Now we're going to need to loop through the obstacles to do the same thing that we got here. So const obstacles equals world.get entity by type, types.obstacle. Now instead of this game state.get obstacles.for-each, this is going to be obstacles.for-each. And now we can reset the game. We could jump, We can survive. We can reset the game like that. We can't score yet. Okay, so we need to fix that. So scoring. Did we score? So how do we know if we scored? Well, if an obstacle was to our right and then an obstacle is to our left, we know that we scored. How does the entire scoring system work? Let's see. So we have a jumped over obstacle event that's currently passed into game state. And we need to notify the jumped over obstacle event that we've jumped over an obstacle. So that sounds like in our draw function here, we can have did we score, we'll take in the world and a jumped over obstacle event. That's like that's what we care about. Okay, so we need to get the player, we need to get the obstacles. So const player equals world dot get entity by type, types dot player. Then we need to get the obstacles. So const obstacles equals world dot get entity by type, types dot obstacle. All right, so now we have everything we need in place. We now need, so what is the next thing? Is going to be player obstacles. Check to see, so for each obstacle, check to see if it's first to the right of the player and then to the left of the player. So loop over all the obstacles. So obstacles for each, get an obstacle. All right, so now we're looping through over all of the obstacles. Now we want to see, is an obstacle to the right of the player? So how do we tell if an obstacle is to the right of the player? Well, obstacles have a location, an initial location, and okay, they have just a plain location here, and they have a triangle. So I think this location X, then how is this drawn out? This location at X, so that's X and Y, so that's wherever that is, and then this location dot X plus width, so that's to the right, and then the Y. So 1 point, a second point, like that, and then a third point. This dot width divided by half, this dot height. Okay, so this location dot Y, this location X is actually here, then to the right, and then down into the middle. So that's what it is. So this leftmost point, so we need a width. Okay, so we have everything that we need. We have a width on it, and we have a location. So the location is actually this like leftmost point. And I think that's why our calculation was wrong before. So are we to the left of the obstacle? So is the obstacle to the right of us? I guess that's what we want to determine first. So if obstacle, the middle of the obstacle is to the right of the player's position. All right, so if obstacle dot location dot X plus obstacle.width divided by 2. Okay, so that's going to be the middle of the obstacle right here, or right here, if that's to the right of the middle of the player. So if that is greater than the player.location.x plus player dot width divided by 2. Okay, so if we're to the right of the middle of the player, that's what this if statement is. So we go in here if we are to the right of the middle of the player. Then we want to run our update. Ooh, so that's a problem. Because we need to update. Did we score is actually can't be just run once because it needs to run an update for that. So that's actually interesting. So this can't actually be a function here, can it? Does it have to be part of the obstacles update? How do we want to like determine if we scored? We could go back to our original method, which was if the obstacle is off the screen. I think maybe, how about this? If the obstacle is to the left of the player, it scores. Now, the problem is our player is, we have to determine like, did we score already with this player? So let's add in a method, like a property to this this obstacle. So did we score with it so far? So this dot like score, maybe like jumped over. And we're going to set this to be false to begin with, and then reset. So we're now going to say this dot jumped over equals false, and then we're not going to set it true. I mean, we could set it true here, but here in game, obstacle.for each. If we could just check now if the obstacle is to the left. Let's redo this. If our if the right, okay, let's do this. Oh nope, didn't want to do that. If the middle of the obstacle, so here's the middle of the obstacle, is that if that's to the left, if that's less than the middle of the player, we have scored. Congratulations. We need to notify that we've done a score. So jump over obstacle event dot notify, and we need taken, I think, there's that event system. So the entity and the event. Entity and event. And who cares about that? Who registered for that one? Jump or obstacle event is just new event system. Do we do anything with that? Not really. We're not. Oh, is game state doing something with it? Jump over obstacle event. That's ignoring it. Oh, is the jump over obstacle event just like completely ignoring that something like that happened? When where's our score? Let's draw interface world. Right, it's the player. The player is keeping track of its score, isn't it? So we can ignore this entire event system, can't we? We could just increase the player's score. So the player Where's... Yeah, here's this jumped over obstacle event. Yeah, reset is this dot score is equal to 0. So let's just, in game here, let's just ignore this entire jump over obstacle event. I don't think this is really helpful for us. We can now do, using this like ECS kind of like hybrid, sort of like messed up system. It's not a very good ECS system. But we can now just say, okay, player.score plus equals to 1. Or we can have like a player dot increment score method on here that does that setting for us. So we don't reach into it to do that. So player, we need to do, yeah, there's an increment score right here. So there we go. Player dot increment score. Meaning, you don't need this jump over obstacle event like that. You don't need you. You don't need you. Jump over obstacle event. I don't think anything. Oh, so on notify, we don't really care about this. It's only checking to see if we jumped over the obstacle. So there's that goes away. Now in the game, so when we create the player, we don't pass you in anymore. Did we score? Just check to see there the obstacle. We're going to increment the score. And then we have to run, did we score? Let's go to draw here. While we're running, let's add in, did we score? Pass in the world. All right, so notice that our score goes up by quite a bit because it's not resetting. So we need to add in to the obstacle that we scored. So we've been jumped over. Like has been jumped over. So let's see, was jumped over. Let's do this dot jumped over equals true. So save that in game. Then we can come down to did we score? I'll do obstacle dot was jumped over. And now we should only get 1 point when we jump over. Ooh, nope, that's was jumped over is not a function. Did I just not? Was jumped over. Did I completely misspell that? No. Okay, so obstacle there. Okay, so obstacle was jumped over. Oh, we need to check to make sure that it's true. So obstacle to for each. If this, the O was lowercase. Oh, okay, yeah, that would do it. Also, thank you, Tensei. So we need this to be checked, and we need to make sure that the obstacle is in a not jumped over state. So obstacle dot, and we can check this up here. Jumped over. So I'll just copy that so I don't make that mistake again. So, and essentially we're in a not obstacle dot jumped over. So save you. And now we should only get 1 point when we jump over. There you go. So we're kind of implementing the ECS system here. And then we can die. and reset the game. All right, so now we have a score. We have the obstacles. The obstacles are resetting. Let's go ahead and send this code up to GitHub. So let's see. Obstacles are now entities. So obstacles are now entities. And push that up. Okay, next thing we want to do, and I think the only thing I have time for before we get to the trees, which is I think going to be a much, much bigger problem because of the entire removing trees as opposed to just resetting them, is I want to increase the speed every time we score. So right now, I think game state was increasing the speed. So that's initialize game speed. Wait, was that happening in the game here? Right, okay, so game state, set run speed. We're just increasing the run speed every single frame. That's maybe a little bit too much. What we want to do is have the obstacles, like all the obstacles, increase their speed every single time that we score, which is pretty simple here. When we score, we also want to now increase our speed. So let's go into obstacles, and we'll have a increase speed method. So increase speed method, and we're going to say this dot velocity dot add, and we'll have to have like an increased speed by velocity, or we could just like we can also just set the you can just say dot x minus equals like 0.1 or something like that. Maybe let's do 0.5. I think that's going to be a lot more noticeable. And then in game here, we jumped over, and then we're going to say obstacle. Do we want that obstacle to increase speed? It's a good question. If I do this obstacle, that specific obstacle is going to get faster, but it's not going to increase the speed of everything. Probably. And when I do it, like I don't want to do it when it goes over to the left either and go to reset. I want them all to increase at the same exact time. So maybe we need like another function, increase speed, which is going to do the exact same thing here. So we're going to have a function, increase speed, take in the world. So we have const obstacles. In this case, because we're only doing one thing, we can even just combine this together into, one essentially one liner, even though it's multiple lines here. We're going to do world.getEntity by type, types.obstacle.for each, get in an obstacle. And then from here, we're going to just run obstacle dot increase speed, like that. Okay, so that's going to increase our speed. Now we want to run this at some point of time, and maybe it could be like every X ticks. It could be every time that we score. If it's every time there's a score, that could be a reason that we use the notification system. we could also have like the world have like the speed that it's doing. But did we score? Can I run? I could just call increase speed and pass in here. So if we do this, then we're going to call increase speed, pass in world. And so now it should be getting slightly faster every time we successfully jump over an obstacle. And it feels, yeah, this is definitely getting faster as we go along. Also, it's not as hard as that previous game that I made. So that's a good sign. I mean, we might want, we need to like reset the score when like everything gets reset. That's definitely not happening. So when we reset the game, where is that go? Where did that go? We have reset. Okay, restart game. We have player.reset, obstacles for each, obstacle.initialize. Oh, and the game state initialize speed. So here we just need to obstacle.initialize. Initialize needs to reset the speed to whatever the initial velocity is. So we'll do this dot initial velocity equals this dot velocity dot, I think it's clone, either clone or copy. And to initialize is, yeah, okay, so it's copy, clearly. Then we'll say this dot velocity equals this dot initial velocity dot copy. All right, so that should reset the game. What are you upset about? Can't access property copy. This dot initial velocity is undefined. Where is that? Obstacle, line 40. Oh, wait, does this not happen initially? On line game and setup, we call initialize. Oh, okay. So that's interesting. We kind of want, when we create the obstacle, does that not create the initial velocity too? That's interesting. So in game, line 13, here's the new obstacle. I would think that when we create the new obstacle like this, we haven't run initial, wait, have we run initialize? Oh, initialize is here. Let's just move that down here. We'll get to running pretty fast. Okay, so there it's clearly faster, and we're back to slow again. Okay, perfect. So the game is working. We've reinitialized and like speed. So game gets faster every time we score. So this is the first time we've now improved the game by switching over to this system. All the other ones are just refactoring it to making it easier to work with in the future. Okay, so I've got the code that I pushed up here. That is at Bang repo. So if you want to go take a look at that code, that's where that is. I am unfortunately going to have to go and run to my daily stand-up with my team. It's the end of our sprint, so lots of fun meetings today. With sprint planning, sprint retros, and all the fun things that come with Scrum. So With that, I'm going to switch to my ending screen. I'm going to be doing this again tomorrow morning, and we'll be implementing the trees into the entity component system that we're sort of kind of creating. But anyways, thank you everybody for watching and stopping by. I've been enjoying learning these and improving this game, and I know I'm improving my skills for doing game dev. I hope that this has been, good for you as well. If you follow me here on Twitch or Twitter, you'll get notifications for when I go live. Anyways, have a great day, and I will see you next time.